So when we talk about magnetic field lines, you must have written point number 1. They start from north side and move towards south pole of a magnet outside the magnet. Okay. Then second point, the tangent drawn on it gives the direction of magnetic field. Tangent drawn gives the direction of magnetic field. Then third can be, they never intersect each other because two directions of magnetic field at one point is not possible. Written. This you can show with the diagram also. Let's say these are the two lines, magnetic field lines, which are intersecting. So possibility is there can be two direction of magnetic field at the same point. Practically it is not possible. Okay. And since inside the magnet they move from south pole to north pole, so they form a closed continuous curve. Okay. They move from south pole to north pole inside a magnet, so they form closed continuous curve. So these are few characteristics or properties of magnetic field lines. Is it okay? Hello, is it okay? Now let's draw magnetic field lines. So all of you write, draw magnetic field lines due to a bar magnet. Okay. Draw magnetic field lines due to a bar magnet. So when we talk about a bar magnet, then how can we show the magnetic field lines? Okay. What you do, you just make an outline of a bar magnet. Okay. In that, write north and south poles. Then you draw two horizontal lines, left side and right side, and then mark arrow like this. North side, it should move away from the point. South, it should move towards the point. Then inside, it must be from south to north pole. And then outside, you draw like this. Outside the magnet, you draw like this. And then put arrow outside the magnet, it moves from north to south. And inside, it goes from south to north. And this is the magnetic field lines due to a bar magnet. Okay. Yes, sir. Then write next. Magnetic field lines due to a current carrying circular loop. Magnetic field lines due to a current carrying circular loop. Okay. So what you do, you make a circular loop kind, but it should not be a complete circle. It is like this. Okay, which means from one end of the wire current is entering and from other side it is leaving, but most of the part forms a circle like. Okay, now let us think about this left side portion. So this part can be taken as a straight wire, and if you hold a straight wire in which thumb points the direction of current, then this is the anti-clockwise direction of field lines. And when the current reaches here, then again if you draw a circle, then you will find that if you hold pen or pencil and keep it like, then field lines are clockwise. So you can have a clockwise arrow on this circle, and then inside this circle along this arrow you can mark these arc like these are the field lines, and in between this arrow should be straight. So this is magnetic field or field lines due to a circular loop. Okay, okay. And then third one is magnetic field lines due to a solenoid. Do you know solenoid? What is a solenoid? Anyone? It is a solenoid. Solenoid is basically a spring. Solenoid is basically a spring having big diameter or bigger diameter. Okay, and size or length is also bigger. So if you draw like this, this spring kind structure is a solenoid. Okay, then we assume that current enters from left side and it is coming out from right side because it is in circular loop. So we have a rule called clock rule. CLOCK, clock rule. Okay, this clock rule tells us how to decide or determine the direction of polarity. So let's say there are two loops. First loop, current is clockwise. Okay, and in second loop, let's say current is anti-clockwise. Clockwise and anti-clockwise, hope you understand. Now in both the loops we try to write something along the arrow, and thus in left side we find something like S. ये S कैसा है? लेटा हुआ S है. S for South Pole. And if you see right side, this is along the arrow we try to write something which is an alphabet N. N stands for North Pole. So this we keep in mind that whenever we have a loop in which current is clockwise, south polarity will develop, and if current is anti-clockwise, north polarity will develop. So just assume left side we have south pole and right side we have north pole. What happens inside a magnet? It moves from south to north pole, and from north pole outside it is like this. So north to south, north to south, okay, and from south it goes inward, from north it goes outward, and this way we draw the magnetic field lines due to a solenoid. Okay, so all of you draw. Drawn. Okay, so this is the idea about the magnetic field lines and how to draw field lines. Right? Now some other aspect which is called force on a conductor. Okay, so all of you give heading force on a conductor. Force on a conductor. For this, let us have a diagram, and diagram is like this. Means so many are talking. So the diagram tells us we have a conductor of certain length. Let's say conductor is PQ, and this C-shaped letter is horseshoe magnet. Horseshoe magnet. This black one is a conductor of length L, and this is a stand. This is battery, and this is key. When we switch on key, there would be current in this. So this PQ conductor is connected with the current. So current will appear across this also. and this conductor is placed in the influence of this horseshoe magnet. So there is magnetic field also. So under the influence of these two, current and magnetic field, it was observed that the conductor PQ deflects, moves back and forth, something like that. So this motion force on the conductor is given by BIL. B stands for magnetic field, I stands for electric current, and L stands for length of conductor. Which means if you want to increase force on conductor, we need to increase the magnetic field, current and length, either of the one or all three. Then force will be stronger. If you want to reduce either of the three, we need to reduce, and that way force will reduce. Getting? All have noted? Then after this we have Fleming's left hand rule. All of you write. Fleming's left hand rule. Nobody should talk. Fleming's left hand rule. Who is this talking? When it comes to the Fleming's left hand rule, all of you see whiteboard and try to understand. Let us have, these are the three, these lines represent fingers, left hand, which are perpendicular to each other. This one is forefinger. Do you understand forefinger? Forefinger. This is forefinger. Then this top one is the thumb. Okay. And then this one is central finger. Central finger. Basically, this Fleming's left hand rule is used to apply the force on a conductor when current and magnetic field are known. Okay. So this we learn from daily life. If this is the left hand, and in daily life, we call this father, mother, child. Okay. Father means force on conductor, mother M for magnetic field, and child for current. So whenever child for current and M for mother, these two are known, we can determine the direction of force on the conductor. Okay? Yes or no? Then all of you write statement. All of you write. If three fingers of left hand if three fingers of left hand are held perpendicular to each other, perpendicular to each other, then forefinger forefinger indicates the direction of magnetic field. Forefinger indicates the direction of magnetic field, and central finger gives the direction of current. Central finger gives the direction of current, then thumb points the direction of force on a conductor. Then thumb points the direction of force on a conductor. So again we need to understand that the two must be known, which are forefinger for magnetic field and central finger for current. When these two parameters are known, then we can determine the force. Okay, like there is a question in your NCRT. So all of you look at that question to apply this left hand rule. Question is, when, let me draw, then you'll understand the question. That question is like this. These parallel lines are magnetic field, and this one is the direction of motion of electron. Then we are told to find the direction of force. Can you see this? The parallel lines are the magnetic field. An electron in the magnetic field enters like this at 90 degree. Then in which direction it will experience force. So how to apply this? While applying, again we need to apply this left hand, which means left hand will go like this, and this one is the magnetic field in right hand side. An electron is coming down, but electron is not current, electron is charge. So current goes opposite of charge, so we need to invert this. Okay, if we keep this is the direction of current, so along this is the what, then we need to keep it like this, opposite of the electron, 180 degree. So now field remains same, this remains the direction of current, then this is the direction of the force experienced. Okay, so accordingly we answer. So different type of questions you can find, and then you need to apply and learn. Fine. Then you have, I think, last topic, which is all about the domestic electric circuit. Okay, so let's have diagram first. Domestic electric circuit. Okay, When it comes to domestic electric circuit, what you know about domestic electric circuit? Any idea? Anyone having? Yes. So our domestic circuits are connected in parallel. Why they are connected in parallel? Why they are connected in parallel? Due to two factors. Two factors. Because each one will be getting same potential difference or voltage. How much is the voltage is domestic supply? 220 volt. 220 volt. And second advantage is if one is not working, then others are not going to be affected. So these are the two advantage. Then next you see in the domestic circuit, along with device, switches are connected in series. Next aspect you see, there are two types of pins. One is 2 pin, other one is 3 pin. Okay, the device which needs little lesser current, for that 2 pins are there. Okay, and device which requires more current like AC, geyser, electric iron. In these electrical devices, you will see 3 pins are there, and in that the third wire is called earth wire because the additional current or extra current will go into the earth, and thus it protects us from any electric shock or something like that. Okay, and then we need to draw the diagram.